All right. On the SIP jig bore, you kind of kneel down. I'll show you. I installed an LED lamp. All right, it's a good angle for you. It looks like a twin tube fluorescent, but it's LED, and it fits rather nicely underneath the cross rail. Let me turn it on. I can better show you how it looks. Get the switch. I got it wired in to the main contact switch. It's the power coming in, and this out the top is the lamp. The old bulldog contactor there. Boom. How attractive is that? Let me kind of kneel down from the back. I hope it's not blowing out the lights, the camera, but there it is from the back. See, it's on the cross rail that goes up and down for elevation. Remember I said I think I have 26 or 28 inches of Z height. So I got an SO rubber cord, and it loops in the upright, and it comes down, and I just got it dangling going in the top of the box. And I put it in the top of the box with a 90-degree fitting because there was a knockout there. I didn't want to put another hole in the box, so I just used that. So, oh yeah, I'm very happy. Let me go around the front. With this lamp, it lights up the table so wonderfully. I got a blue shop towel rag there. It just lights up that table. Awesome. It's tremendous how this thing, let me get another shot with it on, if that's not flooding you out. But boy, oh boy, I'm telling you, there you go. This thing is so bright, and it's 2/10 of an amp. It's ridiculous. It's got not a ballast in there, but I guess you'd call it maybe a current limited power supply or something. But it tucks right up in there nice. Illuminates the table. And let me show you what I did. It's a similar situation. I was going to put one on the top. Let me move back. The top rail, not the cross. See, it's got webs in the casting for strength, and these cross webs. It's the same thing in this movable bridge. These cross webs. So what I did is I got a couple extra here, my bar stool. I used these beam clamps made for hanging conduit off of girder beams, I-beams, and tapped 1/4 and 1/4. So that worked very well. Just got that going on the SIP jig bore. And like I say, the more modern, later models have, I believe, fluorescent lights in them. So that's kind of cool, modern edition. So let me back up, tripping on extension cords. Okay, the Hendey. 1951 Hendey tool and gauge maker's lathe. Before Barbara Coleman bought Hendey. And I've been to the Hendey, the old factory in Torrington, Connecticut. And let me kind of take you around here. I know there's no carriage and no tailstock, but I have those up in the other garage, and I gotta just clean them up and put them on. But this thing took me 4 years to clean. You can stare at that while I talk. To clean everything and de-rust everything. This chip tray had was full up to the top with ice when I received it in Buffalo. But let me see if I can kneel down here. This wiring, I'll kind of show you. That's the original wiring, and everything pretty much works. And I love the detail. Those are solid core wires, and they just bend around the corners, and they just make such a neat job of it. Yeah, Very nice. It's a motor generator, and the on-off buttons, there's the rheostat and the original motor. And I'll take you on this side. Let me just show you guys while I'm up here. It's got a back gear in the head. Very similar competitor lathe to the Monarch 10EE, the 10EE. The Monarch 10EE has the back gear on the motor, which is troublesome when you have to retrofit motors. You have to take the gearbox and fit it up to a different motor, which is kind of difficult. But on these, the back gear is in the headstock, so all you have on the motor for this is a pulley. It makes it nice to retrofit, but I'm kind of doing something different. Let me go on the back. I know this is kind of... Alright, so there's the original motor. There, big, it's a 3-horse DC motor. We'll talk about that in a minute. And then here, there's a, let me stick the camera in there. It's a little dark, but that's a motor generator. And you might be able to see, there's a vacuum tube there. You can kind of see the light going through it. It's a, I believe it's a mercury rectifier tube. And that makes DC for the field coil. But anyways, the deal is, 3-phase is supposed to run that motor, which is internally coupled to a generator, I guess a dyno motor. And with DC being rectified by that tube, which it works, it glows purple, it's pretty cool. I guess it's fed, oh, I can hold the camera, I got a rheostat in there. Well, it's kind of dark in there, but there's a rheostat. And see, this motor is a, let's see if we can see it. It's a Reliance DC motor, and that's the thing. It's 230 volts DC. Shunt wound, which means there's 2 fields. The armature is in series with 1 field. The brushes are in series with 1 field, and the other field is separately actuated. And what the deal is, with this motor, see, it's just a belt drive, and it goes up to the intermediate there. It's a Ward-Leonard setup, popular with elevators back in the day. And what the deal with the Ward-Leonard setup is, it's got field weakening. So I guess these are kind of set up with a shunt wound motor to be torquey, have a lot of torque, but RPM is somewhat limited by the back EMF. So what happens is, at half of the rheostat setting, field voltage on the secondary field is increased up to halfway on the rheostat, and then it starts tapering back. And it weakens the field to allow the motor to spin at a higher speed. And so you have high torque at low RPM, and then the speed is capable up to, I think this lathe is 2,000 RPM. So basically 0 RPM to 2,000 RPM. And like I say, here's the, I got the covers off, the reversing switch, and 3 belts drive the spindle. And there's the back gear, of course. So this is all good and well, but I just don't like going from single phase, which I have, and then I know I have a phase converter, but single phase to 3-phase to DC via the generator, back to the spindle motor. So you got 3-phase motor, DC generator, DC motor. So anyways, to maybe eliminate some of that craziness, I got a solid state drive over here. I'm kind of kneel down. This is a Minarik XL 3300A, and I thought it was pronounced Minarik, but I talked to the president of the company and he assures me it is Minarik. Anyways, this drive it's I don't know if I can show you the input there. No, maybe this camera is blurry, but anyways, input 115 and 230 volts AC, one phase, 15 amps input. Now the output to the armature, you can go 0 to 130 volts DC or 0 to 240 volts DC at 13 amps. Now my motor is 230 volts DC at 12.5 amps. So this is sized absolutely perfect for this 3-horse motor that's on my lathe. And it's got a field output of 100 volts or 200 volts DC at 1 amp. So anyways, got some Skookum big capacitors there, smoothing out the DC. This Minarik drive is one of the only drives that I have found that puts out 230 volts DC. Most of these drives are 180 volts DC output. And to boot, this is also single phase input. Some of the drives, like a VFD, you need 3 phases coming in to take away some of the ripple going through the rectification circuit. But I guess this single phase, it has some capacitors to take the ripple out, make a nice smooth waveform. And I'm kind of give you a down shot. I'm looking at this drive and I'm seeing capacitors. There's actually a full wave rectifier there, little transformer, adjustment pots for a whole bunch of different stuff, fuses. I didn't see any microprocessors or anything. It kind of worried me, but I can assure you the top of the circuit board is all full-size componentry, and if underneath the bottom there's like insulating paper, fish paper. There's micro circuits underneath there, surface mount stuff, microchips of various sorts. So I can assure you this is you know, it's got the microprocessor to make all the important decisions about the electrons and pixies, whatever you call them in your area. Big beefy heatsink. Kind of get a side shot. So it's got like an L-shaped flanged heatsink mounted to this big finned heatsink, and you can see. I might kind of bend down. Underneath the top board, there's some. I guess SCRs or IGBTs or something sandwiched in there for heat transformation through the heatsink there and the fish paper, whatever that is. So I'm excited about this Minarik. 230 volts DC, 13 amp output, pulse width modulated DC control board. I've looked on the Monarch lathe forum on Practical Machinist because the Monarch forum, the 10EE is it's like a cousin to my lathe. It uses the same motor, whether it's a Reliance motor or a GE motor, but it's the same 230 volt, and they got the same motor generator drive for the Monarchs, and they also got tube drive with Thyrotrons or something, or works in a drawer, but I think that still has tubes. I don't know. But they're always looking for a solution, the Monarch guys. But they don't have the nice pulley on their motor. They got a gearbox they got to retrofit if they want to go 3-phase. I could have gone 3-phase, but my motor is fine. So I've got this Minarik drive. I'm going to install it and evaluate it and check the speed and the torque and see maybe it is a good solution for some of the folks that got the Monarch 10EE lathes out there. And I'll post a video of this, of course, and I'll get on with Practical Machinist in the Monarch forum if this is successful, to try and share it with some other guys also, because I think this is kind of a neat drive. Till next time, this is Doozer Shop.